All right, so hello everybody. Hope your week has been going good and happy Friday. So this is part 2 of the Alteryx server webinar series presented by Data Meaning. Just a little quick recap from last time and a bit about myself. My name is Stephen Morgan. I am a professional services manager for the Data Meaning Enablement team. Data Meaning specifically is an end-to-end data solutions company of which we are well-versed in helping you start an analytics progression and take it all the way through to its completion and into that end reporting component. We are premier partners of Alteryx, and many of us within the enablement team specifically have actually been working with Alteryx for a great deal of our professional careers. For most of us, prior to joining Data Meaning, we have kind of been on that user side and kind of ran into a lot of the different challenges and things that you would encounter as you're kind of trying to get things built up and start getting out the data the way that you're looking to deliver it to your end users. So for me specifically, I specialize around some of our standardization, our best practices, and kind of helping get that step towards automation and efficiency so that when you go from that development mindset, you're starting to implement a full production process and can really get things ramped up for your solution. I am certified in Server Connect, as well as partner certified and all the other standard ones such as Core and Advanced. I have been working with Alteryx for a little over 7 years and have had 13 years experience within the business intelligence purview, mostly from an IT-centric focus and then moving deeper into analytics as time went on. So it's a little bit about me and Data Meaning. I have some of my fellow colleagues with the Data Meaning team up in handling some of the questions and answers that you might have. And of course, at the end of this session, we're going to leave some time to discuss some questions openly as well. So just brief recap of what we've already covered. We covered in our last session the introduction to the Alteryx server, where I went over some of the core functionality and the beginning pieces of the server environment. And we have that available. The full recording is available on the same page that you go into for the server webinar series itself. So I'll leave the recap for the next steps whenever we get to those in the following sessions. But today, we're going to be covering expanding out some server scaling. In the previous session, I had discussed very briefly some of the opportunities that are available for scaling your systems. But this time, we're going to take a much deeper dive, kind of show you some of the inner workings and mechanics behind that, as well as showing you some justification and reasons as to why you should consider scaling if you need to get certain thresholds met. So as a brief agenda here for what we're going to cover in this session, the first thing is kind of a general overview where we're going to talk about scaling, kind of evaluate whether or not you need to scale your environment, what are some points by which you can scale, and what are some just templated references that you can use for a deployment. Later, we will move into the database component and start discussing some of the mechanics behind that. How can you scale it? Certain options available to you. Doing the same within the Alteryx gallery and the worker as well. As you can see, the worker contains a lot more to it. And that's normally when we speak about scaling, the general thing that most people try to address and scale first. The reason being is the workers are what is doing all of that heavy lifting, and that is where your resources are going to in terms of running a workflow. Lastly, we're going to go into some benchmark testing, and I'm going to show you some examples as to how this makes a difference as you start scaling out your environment. So the first little bit here, just talking about an overview of what is available in terms of scaling your Alteryx server environment. So as before, what we covered in the previous session, there are many reasons for scaling, but some of the major ones are that performance demand. If you need to start getting things through faster, maybe you have hardware or some different machines or systems that are not being utilized to their full potential. That is another reason. Expand out, use those resources that you have so that you can get through all of these workflows and all of these processes more seamlessly. Redundancy and failover. Most companies have certain plans around backups and restores, but they don't necessarily have plans in place for emergency situations, such as systems completely going down. So you never want to be in a situation where your production environment goes down and you are left without some means to still operate, if even in a limited component. And then of course, cost is always a factor for scaling. Sometimes it's saving cost in terms of time. Sometimes it might actually be a discussion about how much of an expense are you willing to invest for the sake of getting more out of your environment. So some of the points of that scalability, as I kind of mentioned in the agenda, we talk about your worker nodes, your gallery, your database components. Each of these are key metrics by which you can start expanding out your environment and start leveraging some of the greater power that is behind the Alteryx platform. Some of the different things to kind of keep in mind if you were looking for a particular outcome or a particular objective in terms of your scaling. Here's a good reference table in order to get a perspective of, okay, if I need to make sure that I am speeding up how fast my workflows are going, you can see here within this area that the worker node is what you would want to start scaling if your execution time for a workflow is taking too long. If you want to start getting things faster, that would be the resource you want to invest in. If you're interested in looking into something from a user experience perspective, maybe this is something that you are either cluttering up your environment by too many people accessing analytic apps, or perhaps you're trying to get it to the point where you can have multiple users access the environment on a large scale and not actually have a slowed or delayed process in their operations. So kind of continuing on, this is just kind of a sample overview of some templates by which you can set up deployment. Most of you guys are familiar from last time, that single node deployment where you've got your designers connecting in, they're using the gallery connecting in, and you just have a singular server that runs everything. And that's good in a small situation, but as you start building out, as you start getting in more users or start building in heavier duty workflows, you need to start taking into consideration, well, if I have a server that's running literally everything, it can't allocate enough resources to each of these particular functions that I need it to. So then maybe the question is, do I start building in worker nodes? Do I start considering building out replica sets in order to help build some redundancy, or maybe even offload some of that databasing process? Or maybe the issue is on an interface side where users are constantly using analytic apps and you need to find a means to create some load balancing with your galleries. There's a lot of options available, and the idea is to find what works best for your environment. So what we're going to specifically move into is kind of a discussion around each of these. So that worker, that database, and the gallery component, specifically as well as the load balancer options. So first, I believe we're going to go ahead and jump into the database. So the next part, scaling out your MongoDB environment. So here, when you're trying to consider, should I scale my database, there are certain questions that you need to ask yourself and certain things that you need to be aware of. First off, Do I need to scale for performance? Do I need redundancy? What is my data backup plan? More importantly, what is my failover plan? And the last major component here is, should I use a standalone MongoDB? The big reason why you want to take into consideration that last question is because when you are scaling pieces of the Alteryx environment, most of them remain intact and holistically within the Alteryx platform. The only exception to this is MongoDB. When you are leveraging just the standard deployment of the Mongo database environment, it is built into the Alteryx server. However, to scale the MongoDB environment, you will now need to move to a standalone Mongo database environment and manage that and have it connect and associate with the Alteryx server. So that is something to be mindful of, because if you go this route, you will need to make sure that you have an environment set up and you have a DBA able to help support this solution. Now, some of the reasons why you would consider this: again, performance, redundancy, failover, disaster recovery. These are very huge reasons as to why scaling and building out your database environment is important. For beginning environments, it may not be necessary, but the heavier load you put at your environment and the bigger the scale of your production, you need to have some stability. So some of the different ways by which you can scale is you have vertical scaling, replication, and sharding. Now, vertical scaling is exactly as it sounds. You are keeping things within that singular MongoDB solution, which can still be embedded into the Alteryx server. But what you're doing is you're going to start adding in more cores, adding in more hard drive space for not necessarily the database, but maybe for other components, more RAM. And this does work. It does help speed things up. But as everybody knows, as you start putting more and more into a singular system, it gets more expensive. But it is an option for some sort of scaling. The next and most common method that I have seen for scaling is building out what is called a replica set. And what this would mean is you have kind of created your own internal failover for your MongoDB environment. And I'm going to go into the replica set in just a moment. The last one is sharding. And this is when you start bringing in some of that mindset and some of that principles from more data lake-esque type of solutions. When you start talking about, okay, I want to start distributing some of my resources across multiple machines to help process things faster, or in order to get more use out of my environment. I would not recommend going into sharding if you are running a small environment, but if you are talking about hundreds of users, each with their own workflows and their own processes going, it's worth considering, because then you can start balancing out your workload appropriately. So the next big thing that we're going to go into is that replica set. So from this basic example here, we've got our controller, we have our primary database here. If you have a singular node database, meaning the standard setup for a MongoDB, and something happens and the platform goes down, well, you're out of luck. When this goes down, Alteryx goes down. That means your production environment goes down. Now, if you have a replica set, what you are doing is you are still designating a primary, but now you are copying its information into secondary sets of data structures. This way, and as you would imagine, if the primary goes down, one of the secondaries will immediately take its place, automatically update itself, and become the new primary. And then, of course, as you start building and developing and trying to fix a problem, the original primary then gets restored as a secondary. And it kind of creates this perfect triad to protect it. The advantage here is this allows you to keep things cohesive and keep your processes going and streamlined. The next area here, talking about that MongoDB and that whole sharding cluster component. So sharding itself kind of takes that bit from that data lake mindset where you are spreading across that workload. And this is great for the heavier duty your environment is, and it reduces any resource intensity on particular singular systems. Now, this does save you money in terms of not needing to scale up your environment as heavily, but there are some things that you need to be mindful of. The first of which is you use and operate off of what is called a shard key. And what this is a unique key that allows you to connect and share your information between different groupings of your Mongo database environment. The big importance on this is you have to use the shard key in order to implement some sort of methodology for sharding. So the first of which being that range-based sharding. And what that's going to do is that's going to look at common workflows. So for example, workflows that are part of a cluster, or I'm sorry, of a collection where they will be all collected together and operating and keeps it very consistent. The downside is it doesn't do a perfect job of load balancing. Whereas if you use something called hash-based sharding, it's going to distribute randomly across all of the shards so that you get the maximum amount of resources allocated and you have a pretty solid balance of what is taking place. This again helps reduce that stress on your machines. Some of the other things that you can do though is you can always do what is called split sharding, which to its name, you are going to a shard, you are splitting it into two separate or multiple shards by which they each store different components of data. You can then also do migration sharding, where you are pulling information from one shard, delivering it to the next. So this is a bit more of a complex topic in and of itself, but the idea is you can technically use sharding and in a way some of the mindset of a replica set simultaneously, where you have multiple shards, each with their own containers worth of information and processes. But you can also duplicate them into other shards and use them as part of the failover. So it definitely gets a lot more complex as it goes on, but the advantage and the benefit here is you can get it scaled to a true enterprise level by just building this out. So give me just one quick moment here. I need to actually promote a colleague over to panelist so he can help answer your questions. All right, my apologies for that. So the next area that we're going to go into is scaling out our Alteryx gallery. So we talked about the database component and we're good to go there. But now what about that user side? What about the user experience? So just like before, when you start looking at this, you need to ask yourself some questions. What is the gallery usage for your environment? How many users are accessing this gallery? What types of workflows, the complexity and the amount of workflows are you putting in the system? So small, simple workflows are very straightforward and easy to leverage. However, when you start adding in some additional functionality, or you start building out analytic apps and you're adding in new questions and ad hocs and all sorts of other different things, now you're starting to look at it from the perspective of, okay, what does this experience look like for a user? Do I have to start building and expanding this out because maybe it is bogging down the environment and they're struggling as a result. So the last one is kind of right in line with that, improving some responsiveness. If you have self-service analytics, you need to make sure your environment can handle it. And this stems for the workflow collaboration, the ability to share and view any types of results between users or between a private studio group. There's a lot of things to be mindful of when it comes to scaling out your gallery. Now, before we talk about how to actually scale the gallery, I do want to show you what you are going to need to do that. So the first thing, and the most important part, is going in and grabbing your controller token. Now this again is a bit more IT centric, but what you would need to do is go into the system settings, navigate to the controller, and we are looking for specifically this controller token here. Now, I even put it here in red, and I caution very strongly against this. Do not regenerate your token unless you have no other choice. The main reason is any worker node or gallery node that is connected to your environment is relying on this token in order to keep that level of communication. If you hit regenerate, this creates a brand new one, and you're going to have to go to each one of those systems and put in that new controller token. So be very mindful of that. But once you have your token, you can simply add a new gallery. You can go spin up a new environment, and you can just simply, as part of its installation, go down to custom here, select enable gallery, and you are good to go, because all it will ask you is point to the main server and give me the controller token so that I know what to look at. So it's a very straightforward component. Now, when we're talking about adding a new gallery, something that is required of it, however, is you need to have a load balancer in place. Now, some of the benefits of a load balancer is obviously it's distributing the workload, the incoming traffic, but it is good for maximizing your throughput, for avoiding overloading any particular system, and it helps you keep your resource usage as efficient as possible. Now, that being said, you need to start looking at options available to you for a load balancer. For example, AWS has a built-in load balancer that you can bring in, and you can leverage that in order to help distribute some of that workload. There are many other environments and many other sources available to you as a load balancer, but in order to utilize multiple galleries, you do have to have a load balancer in place. So just be mindful of that. Moving to the next section, we're going to start jumping into talking about the Alteryx workers themselves. And this is truly kind of that meat behind scaling your environment out. Just like before, anytime you start looking at scalability, you need to ask yourself some questions. How many users do we have? How many workflows do we have? More importantly, what kinds of workflows are being ran and how long are these workflows running? You can have 20 workflows on your environment, but if they are massive, heavy-duty workflows, you might already be hitting your own resource cap. And these are things to be mindful of. Not all workflows are created equally, and they differ wildly from department to department, team to team. Everyone has their own unique style of developing a workflow. Some are more efficient than others. And there are a lot of things that you need to take into consideration when you start saying, hey, are our resources enough to handle what we're going to throw at it? Or do we need to start building out this environment more? So to that next part, how should we handle this increased load? how do we scale? How do we get the size going? And then lastly, because out of everything, the worker nodes are that heavier cost, what is your budget available for this? It's easy to say, hey, we want to get the most out of our environments, but if the finances aren't there, it's a lot more challenging. So sometimes you do have to pick and choose what works best for that particular situation. So this kind of leads into that next little portion where I'm going to talk a bit about what a worker node really is in terms of your system and why scaling is such a relevant thing for it. So firstly, let's talk about what engines are versus a worker. Now, in the previous session, I covered what each of these are singularly, but what I haven't touched on is where these two kind of come into play. So an engine is that instance, that resource consumption to run a workflow. As I have here, the more engines you're using, the more simultaneous workflows you can run at the same time. A worker is treated as a server-esque component that can manage multiple engines and spin those up to run multiple workflows. The reason why this is important to understand is you can have a worker node with tons of engines on it, which means you can run multiple workflows simultaneously. But eventually, because it's just the limitations of the server and that worker node itself, they're going to be competing for resources. And when we get into the benchmark testing in a few, you're going to see very apparently how impactful this is. So the first things to consider when you are talking about worker nodes, do you want to start scaling up or scaling out? When you consider scaling up, you are increasing the amount of engines on a worker, which is useful at times. You are also limiting the amount of servers or worker nodes that you actually need, but its biggest drawback, there's increased contention over resources. The more engines you have running on a singular worker or a singular component of your server environment, the more impacted it becomes, the more bogged down it becomes. Now, what you could also consider is taking some of these engine resources and maybe even some of this worker resources, and it's time to split it out. So when you scale out your environment, you build another server or another worker node at least, and you are dedicating some engines to it, some resources here. Now, the advantages. You've got more worker nodes, so you can delegate between them using the controller and the server. You have better performance and throughput. So previously we had 4 engines under this worker. Let's assume all resources the same. Separating it out, you are already going to process things much easier because once you get to a certain point, you are hitting your server too hard and you need to split this apart. Now, the drawback, there is more cost involved. And that is another reason why you have to consider very carefully, do you need to scale? Moving into the next bit here, what I kind of want to showcase is some ideas of, okay, we're not sure if we need to scale. Where do we start? How do we even get an idea of what we have to scale to? So I've got right here a little bit of a table kind of giving some guidelines and recommendations on threshold. Now, the biggest caveat I want to add to this, treat these as guidelines because again, there is no perfect solution here. It is going to be specific to your environment, your business needs, and what you're trying to accomplish. It's very easy to say, hey, we've got 1 to 20 users on Alteryx running workflows, but our workflows only take 5 seconds each to run. Yeah, you could probably get by with a single worker node. But if you have very heavy duty workflows and you start looking up here, sure, you may have 1 to 20 users, but if your workflows are taking a lot of time to run, then you're going to start needing to allocate more resources. And this is common when you are running very heavy duty workflows. In a guideline of best practices and standards, I try to keep my workflows between 30 to 50 tools on a canvas at a time per workflow. Sometimes that doesn't work out as smoothly as I would like. But the idea is if you have some sort of standardizing and some metrics, you can at least try to get that time a little bit lower and to also kind of rein in your process a bit. Because if you have a workflow that has 10 tools on it and it runs in 10 seconds, but then you have somebody else that builds a workflow that has 300 tools on it that takes an hour, it's very hard to gauge metrics off of it because they're not going to be evaluated the same way. So, as I mentioned here, you want to look to get an idea of how many workers you already have and what you need to consider. You need to look at how many users and workflows are being ran, but also the types, the amount, how heavy duty these workflows may be. Benchmarking is probably the best and most effective way to actually get a solution around this. But what you need to do is start looking at multiple guidelines here, that complexity. Cadence and scheduling of workflows. And I haven't touched on this much, and I'll touch on it when we start covering the gallery itself. But a lot of the time, people will bog down their environment and then come to realize that 90% of their workflows are being ran at the same time every day on a scheduled cadence. If that is not necessary, is there any harm in running a workflow at 3 a.m. versus 4 a.m.? Now, again, it depends on your environment, but spreading out your cadences helps mitigate the need from a criticality standpoint to scale. Doesn't necessarily mean that it removes the need or the intent to do it, but it spreads out your resources so you are not hitting your system really hard for a particular point in time, and then the remainder you're not using all of these resources you have. Spread it out if possible. This will save you money and time in the long run. The next part, that benchmarking, having a means of testing and evaluating, and we're going to go into some detail about this. This is the best way to get an idea of what is your environment doing when you run these. And that leads to that analysis of your environment holistically. You are going to want to start doing benchmarking and testing on a lot of different workflows, a lot of different use cases. And you need to start looking at your environment as a whole. You need to start looking at your department, your company as a whole on this. Because maybe, and I know this is going to sound like a horrible statement, but maybe your company is perfectly fine with the reports not being as streamlined because maybe you're doing weekly, monthly reporting, so you don't need to leverage massive amounts of additional resources in order to process something. So they're not going to want to invest that money, and maybe that's not a requirement for your team. And if it isn't, don't spend the money. Save the money, reinvest it somewhere. But it's good to have an understanding of what your environment is going to be required. The next bit there, what is best for your company? And that is very key. Is not every environment is going to be the same. Not every requirement is going to be the same. So my recommendation here is to find what works best for your environment, for your company, and then start looking at scaling in terms of your workers. So going a step further into the workers themselves and a bit of how they operate, I want to kind of talk about how they associate with a controller. So the controller itself in the worker nodes actually operate in a very cool mindset. It is a whole hub and spoke model. And the idea is with the priori knowledge, the controller does not know anything about any worker node or any other worker nodes that will be connected online. So as you can see, we're adding in worker nodes and it all points to the same controller. But the great thing about this, it is seamless, it's very simple, and it allows for you to scale dynamically. Because anytime a worker node connects online, uses that controller token, like we mentioned before, and connects to a controller, that's it. It's good. That worker is now online and able to be leveraged as resources. And the reason why this is great is you do not need to restart the service. You do not need to shut down or do anything to impact your production, because the worker nodes talk to the controller and then the controller will send something back. It's not the other way around, so the controller does not need to know whether or not a worker node is online. The worker node will tell the controller, I'm online. This is a great way to distribute and manage your resources. And the advantage to this is it allows you to start taking a look at more complex opportunities. You can go from that mindset of, can I spin up an environment and start leveraging this? Now, granted, yes, there are licensing and resource costs and different things like that. But the thing is, if you've got your environment set up in a certain way, you can spin your worker nodes up and down and actually make the use out of your resources while not spending as much money on it if you were operating out of more of a cloud environment or something a little bit higher scale. So there's a lot of versatility here, and I think it's a great model because you can really build the environment that works best for your situation. So now that we've kind of covered scaling, I want to talk about benchmarking and kind of go into detail as to what the benefits are here. So this first bit, the benchmarking methodology. There is not a perfect solution here. Every environment is different, and the only way that you're going to get a good understanding of how do you scale is to test, because your strategies will evolve based on the needs of the business. And you have to always account for, what is this going to look like 3 months, 6 months, a year, 2, 3 years down the road? Have that in mind when you start considering these. Know where to look at, know what to look at, and test extensively with actual data in actual situations. Because if you don't do that, you are not going to have an accurate depiction of, hey, is this going to be a problem in the future? Testing in a bubble does not yield positive results. So moving on a little, talking about some of that resource and worker usage. We talked about how many engines should you be running on a worker node? Should you be splitting this out? Should you scale up? Should you scale outward? Are you going to need more RAM? Are you going to need more processing power? Some of the concepts behind this. In terms of processing power, you need to leverage, if you were leveraging spatial or predictive analytics, you might need more processing power. But if you were pulling in massive data sets, things like Calgary, you would need more RAM. These are all things to keep in mind when you start building out your scaling environments. So what we're going to do here is show you an implied use case. So what we're looking at here is we're going to be testing some different workflows, and we're going to monitor workflow throughput and engine throughput. Workflow throughput is regarding how many workflows complete across runtime, and this is brought to how many workflows complete within a minute. The engine throughput is how many workflows are running comprehensively in terms of that engine's consumption of resources. The goal, maximize both. You don't want to bog down your system and you want things to run fast. So give you some perspective for the rest of this test. We're running one RAM intensive workflow. We're running one processor intensive workflow, and we are going to queue each one up 5 times. So we're running 10 workflows, and our average is to see how many workflows ran per minute, per engine, and per holistically. Our system itself fairly robust. 4-core, 32 gigs of RAM. We have 2 solid states and a physical drive. Alteryx is on the solid state. And we have the data packages, like Calgary, on a spinning disk. So this first example, single node deployment. If you notice over here, when we're looking at this, the workflow throughput, the engine throughput, they're identical. It means that the system's not being taxed. We queue up everything, they run, they process as they normally would. There really is nothing crazy about it because with one engine, we're only running one workflow at a time. So let's expand that. Let's build on this. So now we're going to build this out. And this is the recommended. So from an Alteryx recommended standpoint, I'm going to touch more on this in the next session. They recommend for every 2 cores you have in your server or system environment, you want to leverage 1 engine at maximum. So this right here is what the standard expectation would be. You have 2 engines going and, oops, I realize I have a typo here. This is supposed to be 1 worker. But the idea is you have 2 engines going and you are trying not to impact your environment. You are leveraging your resources and you're getting through your workflows a bit faster, as you would expect by having more engines. Now, here's where things start taking a downturn. So we've got 2 workflows running simultaneously. Let's try 4. Well, if you notice, you did not really complete any more workflows. This is barely an improvement. But now you're competing a lot more for resources. So your actual engine throughput is tanking. Don't worry, this gets worse. So this already exceeds the recommended. Let's go from 4 to 6. Now, when you look at it, 6 engines. So you're running 6 workflows simultaneously on the same environment. If you notice something, you are actually running and succeeding at getting less workflows completed than you did when you were running 2, because you have now bogged your system down to the point it is crippled. And when you start seeing things like this, now you need to really take into consideration, should I be running all of these at the same time? Should I now look at scaling as an option? Because you're going to need to now. So kind of moving a little bit further, we've done our testing, but now what can we do? Let's add a new worker node in. Let's go in here and say, okay, all of this had been done previously on a single node. Let's add in this. So another 4-core, we're going to add in just 16 gigs of RAM, a solid state physical disk. So again, Alteryx on solid state, Calgary or data package on a spinning disk. Now let's see what we can fire out. Well, here's a good comparison. 1 worker, 2 engines. 1 worker, 4 engines. 2 workers, 2 engines, which if you notice, collectively in terms of processing workflows, these are using the same amount of workflows. 4 gets queued here, 4 gets queued here. Guess what? You have almost doubled what it was originally, and you are considerably faster in getting your workflows through. But not just that, your engines are not getting crippled nearly as bad. And this only gets crazier as you start scaling more and as you start considering other components. So previously I'd mentioned for your system and for preparing your implementation to have things like solid states. So consider upgrading to a solid state, because when the disk is spinning, it's creating bottlenecks. And your goal with this is to increase that throughput and get some of that latency out. So now, as a great example, this is back to that 1 worker, so not using 2, which would make this even bigger in terms of an example. But if you're using spinning drives, well, all right, so you're getting through a little bit. But even by comparison, you are getting more on a baseline from your solid state. But where it really shines is when you start running more at it, when you start putting more resources into this, where you were going to go from being bogged down a little bit to almost effectively doubling just the amount of throughput, and they're running the same things, which again, it's not recommended that you run 4 engines on a 4-core server, but you're still getting a lot more out of it by just having a solid state there. So when you start taking that into consideration for your worker nodes and for building things up, now you're going to start really leveraging some of the power behind your environment. And that's the beauty of this. Analyze and benchmark and test what you are throwing at your environment and start looking at these opportunities. Building out worker nodes and having solid states on each one of them, or having that capability, is going to significantly empower your environment. And you will get through so many more workflows faster doing that than you would trying to put it all into one. And at the end of the day, if you balance it properly, you're not going to hit your cost that much. The end result will be more than worth the investment. So that basically covers what we're going to go over for today's session. Tomorrow, or I'm sorry, the next session that we're going to cover is going to focus more on the installation, configuration, and some of your best practices in terms of managing your Alteryx server environment. So different things that would allow you to create your backups and restorations, talking about the services that run behind the scenes. So what I'm going to do now is I'm going to go ahead, take this last bit of time and kind of open it up so I can look through some of the Q&A and address some of the certain ones. Again, we're going to be having all of our recordings available on the webinar page. And if you have any questions, please feel free to ask them here. Reach out to myself, to any of our colleagues, or you can also reach out to our sales group within Data Meaning, because they can help get the right person from the enablement team involved to help you address some of these. So I'm going to go ahead and jump into a few of these here. So let's see. If we need to do benchmark testing and identify which studio is taking the most resources. So don't look at it so much from the perspective of a private studio. Instead, look at it on a more holistic level from workflows themselves, because I can build a workflow that has 10 tools that aren't going to necessarily impact my environment. And I can build something instead that just hammers our system. And even worse, I could schedule the thing to be running constantly. So you need to look at it from a workflow to workflow perspective. And when we go through the admin side of the gallery, I'm going to show you a little bit of what you can do to get some visibility to it. But some of the other things is you can work with that end user or work with that team and start actually building out your own methodology for testing. Another thing that you could do, and I recommend this as a best practice, is if you have your production environment and you have actually purchased the sandbox licensing, try to get your sandbox environment as close to your production environment as possible, because you can do your benchmark testing there. And if you do impact the system negatively through it, there's no harm behind that. It's a sandbox. It exists for that testing purpose. So it's very good to do some refining and some benchmarking to get things squared away and then provide a more meaningful solution. Whether that means not changing a thing and just scheduling it for 3 a.m. when nothing else is running. It gives you more of a means to get a better perspective on how you're testing and how you can deliver stuff. So I did kind of touch on this a bit. Well, your next part here. How does throughput compare when you increase RAM and processing power compared to worker nodes? So think of it from a collective perspective. You can increase processing power and you can increase RAM, and it does scale in a very similar fashion to expanding out worker nodes. However, the one thing to keep in mind is the advantage of having multiple worker nodes, or at least having some worker nodes, is that you can designate and delegate part of your operations to particular worker nodes. For example, I had mentioned in the last session having a data science-based platform. So if you have your primary server, or you may have a worker node or two that's supporting it, and then you have a separate worker node that is purely dedicated to data science processes, whether you're running modeling or whether you are starting to put in data packages, you could put more resources to that worker node and have it handle that. And it is completely separated and removed from impacting the rest of your environment. If you increase just a singular worker node and build it up, you still get that benefit of the added resources. But what impacts you negatively is you are still putting in workflows that may be very resource intensive, competing with workflows that may not take any resources hardly. So sometimes it's fine, but it's something to keep in mind that you may want to leverage that means of separation. Doesn't necessarily mean you have to though. In either case, I always recommend scale, get more resources to serve the business need. And it's going to be something you need to look at on a case-by-case basis. So Nazir asked, does Alteryx have any built-in auditing tool? That's a tricky one because it does have certain capabilities for auditing, but nothing as streamlined as what you would be used to from a standard IT practice. What you can do is you can leverage the MongoDB, the logs, and other processes to get a good handle on what is running, how it's running, what it connects to, how it's using these connections, and actually do a much more comprehensive level of benchmarking behind it. So in the example I showed earlier where I was kind of walking through like just the resources of running the same workflows over and over again, you can get a lot more granular. You can get to the point where you can look through the MongoDB and the logs and bring those even into Alteryx if you want it as a workflow. And you can start leveraging this in a way where you can say, okay, this workflow is 90% perfectly fine, but the second it is pulling from a different database, maybe there's something odd with that connection that it's using, it suddenly tanks your resources. So now you actually have a means to reconcile on a tool level and say, hey, our workflow is great until you add this in, and then it crashes the thing. Well, crash isn't the best word to use, but it impacts it negatively. So to that end, I wish there was a little bit more out of the box for auditing, but it does give you some capability. And what I have seen in some bigger environments is they will pull the logs, the MongoDB environment, pull all of that, build an Alteryx workflow that's analyzing it, and then they will create dashboards out of it. And they have some of the most beautiful error handling logging dashboards I've ever seen, where someone can upload and publish a workflow. It's never ran on the environment, and they can already predict the likelihood it's going to run into an error, where it's going to run into an error, and what points or steps they can take to reconcile that, to bring it into more of their best practices. So you can get pretty in depth with it, but there's nothing that's immediately just right to you that you can access. You kind of have to pull from a few sources. Yeah, so I mean, it kind of follows up with your question there. The only things that they really have out of the box would be more of the diagnostic page on the admin side of the gallery, which shows you a little bit, but it doesn't go deep enough. Not like what the MongoDB and the logs would tell you. All right, so any other questions? So yes, the recording of the webinar is available, and this session will become available on the webinar page itself. Any past sessions and stuff will be available there as well. All right, any last questions? I believe we still have just a few minutes before we need to wrap up. Of course you're gonna put me on the spot, Marvin. So the next session is going to be talking about the installation of the Alteryx server. How do you configure each of the pieces? We did kind of hint at it a little bit when I was talking about that controller token and where to find that. We're going to be going through all of those steps of configuration. And then to move beyond that, we're going to talk about best practices, setting up some backups, and kind of how do you do that restoration? How do you keep your environment intact and kind of build out a setup so that you're building for success? So it's going to be a bit in depth, and we're going to go through each of the configurations, what they do for the environment. And I would imagine this is something that people from the IT system side would definitely want to take part in, because this is going to walk through everything you would need to know to get your server going and to understand what it is you're working with and configuring. So I think that's actually a good thing for us to leave off on. So we'll go ahead and get this recording put in. And thank you everybody for taking the time to attend. I hope you have a great weekend. And as always, if you have any questions, please feel free to reach out to myself, to any of us at Data Meaning, or our sales team that can help get the right person involved in the conversation with you. So thank you for attending, and I'll see you guys next time.